Hello. In this session, I'm excited to present the indexing improvements which we are getting in Greenplum 7. So Greenplum as an analytics plus more as a searchable database. So Greenplum 7 is going to have all these indexing improvements, which makes it much more searchable database along with all its analytics capabilities. Uh, Greenplum 7, as known, will be based on Postgres 12. So many of these capabilities are what we are inheriting because of a refresh of Postgres version to 12 underneath what we use. The BTREE indexes are having improvements. This is the major topic which I'm going to discuss in this session. Other improvements we are getting is there would be a block range indexes. We are going to have primary or unique key indexes support for append optimized tables. Previously, this support only existed for heap tables. We'll have index only scans. We will have covering indexes plus hash indexes have been made much more crash safe and usable now in production environments. So let's dive in and look at what BTREE Index improvements we are getting in Greenplum 7. Let's start with first index improvement. So first index improvement is in terms of performance and space utilization for cases where we have for many duplicates. So if we are creating a BTREE index, which is non-unique, and it is for the columns which have duplicate values in them, then there is difference and improvement in terms of performance and space utilization. So let's walk through the demo and then we can come to the reasoning behind the improvement. I'll walk you through the basic setup which I'm using to showcase the improvement. It's very simple. We create one table which has two columns A and B. Then we create an index on column B. To showcase the duplicate value improvement, what I'm doing is essentially inserting 20 million tuples in the table T with the characteristic that column A is going to have all unique values and column B are going to have some duplicate values. So let's analyze and then we'll know. So this just is information conveying the same thing from PG statistic table that attribute A has all distinct values and attribute B only has like 2000 distinct values stored in them. Now, if we look at the size of the indexes in Greenplum 6 and Greenplum 7, so Greenplum 6 index is 44% larger, or you can say the size of green index in Greenplum 7 significantly reduces, like 44% smaller in size for this case where you have many duplicates in the index. Plus, given the reduction in the size, also helps to insert faster. So as you can see, for Greenplum 6, it was around like 33 seconds to insert these many rows with index versus in Greenplum 7, it took 28 seconds only to insert 20 million rows. So even inserts get faster and the size reduces in Greenplum 7 for non-unique BTREE indexes. Let's walk through the reasoning behind why we see this improvement. So it was mostly the effort bit by Peter and Heikki and Postgres, where the implementation was changed and this enhancement was made. That in prior releases, for duplicate values, there was no ordering followed. So when the tuples were inserted in BTREE, the location was not fixed. Either they could land on rightmost page or they could land in a page in middle of the BTREE. So if a leaf page, which is not rightmost, but a middle page has to be split, the policy is to split that page with half of content. So most of the pages were not like compact or not fully filled. And that's the reason the number of pages required were high. But with the change in Greenplum 7, now all duplicate values are stored in BTREE Index with CTID as the ordering mechanism. What happens because of that is, given all duplicate values are getting stored in CTID order, duplicate values always get stored and locate on the rightmost page of the BTREE. And there is already optimization that if you're inserting to a rightmost page, and if that page has to split, that split does not result in half content splitting, versus the rightmost page splits only the last part of it. So that's the reason the pages are much more packed and compact, which results in smaller index size and faster speed on inserts. The second benefit from this improvement came for vacuuming the table, that if you're vacuuming the table which has these kind of indexes, the index cleanup generates less write ahead logging, plus the scanning becomes faster during vacuum operation to figure out dead index tuples. So all that improvement also helps the vacuum operation. Now, let's move on to talk about the next, the second improvement which we are going to have for Greenplum 7 for BTREE indexes. That is for multi-column indexes. So if you have an index which is on not single column, but multiple columns like composite index, again, it came as having much more space efficient compared to the previous version. Let's see demo for that piece. So what to showcase that what we are doing now is we are creating a unique index, which is primary key index on two columns, A, B. And as the property, we know that A has all unique values and B has duplicate values. So once we have created this index, from the size perspective, we will not see much gain when you look at just the size at the top level for multi-column index. So size kind of remains similar. The biggest advantage you can see for multi-column indexes is if we look deeper. So using the BTREE page stats function, what I'm printing here is the split of pages between like how many internal BTREE pages are there and how many leaf BTREE pages are there. And as you can see, the number of internal BTREE pages are significantly less in Greenplum 7 compared to Greenplum 6. Now, the reason behind having much lower number of internal pages is because each internal BTREE page has become efficient at storing information. So in Greenplum 6, this setup required like 24 bytes of key, versus in Greenplum 7, it's only needing 16 bytes. So like 8 bytes reduction in size. Because of that, the number of elements each internal BTREE page is able to store in Greenplum 7 is much higher. And because we are able to store much more elements in internal pages, it has much greater fan out for the tree in Greenplum 7, and that helps to do scans and much more optimized B-tree structure. Now let's go and see why the reduction happens. So the reduction basically came from is now the internal pages only store the values which are required to uniquely identify a tuple. In Greenplum 6, all internal pages and leaf pages both were storing all the columns which were in index. But with the improvement, internal pages are now storing only the columns which can uniquely help to identify the leaf tuples. So if we go back here in Greenplum 6, given we had indexed on A and B, this internal page of index also stored values for A and B both. Versus in Greenplum 7, given A has all unique values, internal pages can identify the leaf page tuple and all just using column A. So that's the reason in Greenplum 7, internal pages are only storing value for A, even if you have created index on like multiple columns. And that is where the efficiency is coming from. And that efficiency helps us in doing the locality and searches in future. The other improvements to mention is there is improvement to the locking aspect as well, wherein if you are doing concurrent inserts to a B tree and those concurrent inserts fall on the same leaf page, then there used to be like first we used to lock in shared mode and then we need to acquire an exclusive mode, and that locking and relocking used to be having a lot more contention. That has been eliminated, and what that helps us is in concurrent, if it is an ordered insert which is falling mostly on the same leaf pages, it helps to have the speed up of locking exclusive mode first and then helping to serialize those operations. Also to note that given BTREE indexes are also used for most of the catalog tables internally. So all these gains and improvements and reduction in size are also applicable and intrinsically improve all catalog scans and those kind of things. So these improvements are not just for user tables. All these BTREE index improvements help catalog table BTREE indexes as well. So that essentially concludes the session which I wanted to have for this one. All other improvements listed here, we will be having separate sessions for each of them. So stay subscribed to the Greenplum channel to hear about all these improvements and further improvements of Greenplum 7. Thank you. That's all I wanted to share for today.